Okay, gentlemen, here we go. We're looking at section 6.3, graphing quadratics using the x-intercepts, also known as the roots or the zeros of an equation. So here it says, write a quadratic equation in the form y equal ax squared plus bx plus c with roots 2 and negative 5. Well, we know this is standard form, and we know the roots are 2 and negative 5. And then the second question is this the only possible answer? Well, we know to write root form looks something like this. If our root is positive 2, then we write x minus 2. If our other root is negative 5, then we write x plus 5. We've learned this in previous lessons. Now, in this example, the a value is an imaginary 1. I don't have to write it, but we know we can assume that there's a 1 there because we haven't written anything else. So the second question, is this the only possible answer? And the answer is no, because I can sub any value. I can stretch this, right? I can compress it by making that 1/2, and it really could be any number for a. So the answer to this question here is no, can be stretched or compressed by any factor. And that would change the shape of our parabola. Okay, our new learning goal is to notice that the x-intercepts, roots, or the zeros of a quadratic relation in standard form can sometimes be found by factoring. The x-intercepts occur when y equals 0. So when we're solving for x-intercepts, we want to make sure that our equation equals 0. And when the x-intercepts and one, I think what this is supposed to say is one other point, and let me get that out of here, and one other point are known, they can be subbed into the equation. And this is root form, as you know. So let me put that there. And this is, no, it doesn't want to be friendly. And that's root form to find the equation. So when the x-intercepts and one other point are known, they could be subbed into the root form of the equation to find the equation. So let's take a look at this example right here. Write the quadratic equation in standard form to represent this parabola. Well, if we look a little closer, I know my roots are positive 3 and negative 1. So right away I can say y equal, let me put a here, x, and because the first root is positive 3, or sorry, negative 1, I'll write positive 1, and my second root is positive 3, so I'll write x minus 3. But you notice I haven't put anything in for a, I just left it as a. So how can we solve for a? Well, we have two other points. We have 0, 6, and we have 1, 8. So why not shove in 0, 6 into this equation? We'll sub that in, and we will solve for a. So when the y, I'm going to use again sub in 0, 6. And so I'll write 6 for y equal a, and then for x we're plugging in 0. So 0 plus 1 times 0 minus 3. And then we have 6 equal a times 0 plus 1 is 1, and 0 minus 3 is negative 3. 6 equal, we know 1 times negative 3 is negative 3, and we'll write the numerical coefficient in front of the variable, so we have negative 3a, and then we will divide both sides by negative 3 to isolate a, and we get a is equal to negative 2. So we write our equation y equal negative 2 bracket, and then x plus 1, x minus 3. So that is our equation in root form. Remember, the question asked us to represent this in this format. So we're not done. So be careful when you're answering a question. Always look back to make sure that you've answered it completely. Now I find to get this back into standard form, we simply need to expand. But I find it simpler to FOIL these two binomials and then distribute the negative 2 after that's been done. So let's try that. Y equal negative 2. And if we FOIL, we have x times x, which is x squared, x times negative 3, negative 3x, and then 1 times x is positive x, and 1 times negative 3 is negative 3. And I'm going to simplify what's in the brackets. I'm just going to take this. Actually, you know what? I could probably fit one more line in here. Y equal negative 2 times x squared. Negative 3x plus x is negative 2x minus 3. And then we'll come up here. And let's go over here. We have a lot more room here. So we have y equal negative 2 times x squared minus 2x minus 3. Just rewrote what I had down there. And so then we will distribute the negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is positive 4x. And negative 2 times negative 3, of course, is positive 6. And now we've written our equation in standard form for this parabola. And that's that. Next question asks us to find the intercepts, the x-intercepts or the roots, and the vertex of the parabola, and then sketch its graph. So we've got standard form. We are looking for, of course, the first thing you look for is a greatest common factor. There is none. So I'm going to multiply a, we know a times c, which is 3 times negative 2, which is negative 6. Two numbers that multiply to negative 6 and have a sum of positive 5. Okay, and so sum equals 5. In this case, we have the two numbers are, 1 and a positive, negative 1 and a positive 6. Those are the factors of 6 that'll work here. So I'm going to rewrite my equation, y equal 3x squared, and we're breaking down this middle term 5x into positive 6x and a negative 1x, because 6 times negative 1 is negative 6. And then we have our final term, negative 2. Then we're going to GCF each of these two terms. So the GCF here is 3x, take that out, and then we have 3x times x is 3x squared, and 3x times positive 2. And then we have negative 1 times x and negative 1 times a positive 2. We say y equal x plus 2, and then 3x minus 1. So we found the x-intercepts almost. So we need to say here, for the roots, and this was in our learning goals, for the roots, y equals 0. So therefore we have 0 equal x plus 2 times 3x minus 1. I'm just taking my equation here and subbing in 0 for y. That's all I've done. Because we know when the parabola, for example here, when the parabola touches the x-axis, the y value must be 0 at that point. Okay, so now we will, if for this to be equal for this to equal 0, either x plus 2 equals 0. In order to get 0, we need to have, for example, 0 times something, or we have to have something times 0, or we have to have both of them equaling 0. One of those three options. So when we're doing that, this is why we can confidently say that we know that x plus 2, don't need the brackets, can equal 0, or 3x minus 1 equals 0. If x plus 2 equals 0, then x is going to equal negative 2. And if 3x minus 1 is 0, then 3x equal 1. Divide both sides by 3. X will equal 1/3. So those are my two roots. Again, it's a sketch. So I'm looking for two roots, and it asks me also to find the vertex as well if you look at the question. So I found my roots. I want to find the vertex now. How do I find the vertex? So let's do that here. Vertex. We remember the vertex is on the axis of symmetry. So we're going to first find the x value of the vertex. We're going to add negative 2 plus 1/3, and we're going to divide that by 2, because that will give us the x value of our vertex. Then we have negative 2 plus a third. We need to get a common denominator, so that'll be 3 and plus 1/3. And so our common denominator, that's 3, so 1 times 3 is 3, and negative 2 times 3 is negative 6. That's all being divided by 2. And that'll equal negative 6 plus 1, which is negative 5/3, divided by 2. Now some of you prefer to write this like this, equal negative 5 over 3 divided by 2, or 2 over 1. And you should have learned this in elementary school, likely, that 5/3, we can invert and multiply, so we'll say times 1 over 2, and then we get negative 5 times 1, which is negative 5, and 3 times 2 is 6, so negative 5/6 is the x value of our vertex. How do we find the y value? Well, we're going to sub that into our equation. Our equation was y equal x plus 2 and times 3x minus 1. That's our equation. And if we sub negative 5/6 in for x, three times negative 5/6 minus 1, and then we have y equal, again, we're finding a common denominator, so we have negative 5 over 6, and our common denominator in this case is going to be 6, so we'll have, that'll be plus 12 over 6, which is 2, and then here we can cross reduce, make our lives a little easier. 3 divided by 3 is 1, 6 divided by 3 is 2, and we're left with negative 5 over 2 minus, I don't want to write minus 1, I need a common denominator, so it's going to be minus 2 over 2. And then we'll continue here. Y equal negative 5/6 plus 12 is positive, is 7/6 times negative 5. We change that to addition and change the following sign to its opposite. So we have negative 5 plus negative 2, and we get negative 7 over 2. And now we're going to multiply numerator times numerator, denominator times denominator. We get negative 49 over 12. Okay. So our roots, again, negative 2. Say it's about there. And our other root is positive 1/3. Show you a little closer here. Something like that, maybe a little further left. We know our parabola is opening upward, and our x value of the vertex is negative 5/6, so it's not even 1. A little difficult, I might have to blow this up there. Okay, and the y value of our vertex is, double check that down there, is negative 49 over 12. 12 times 4 is 48, so this is just, if you want to convert this as 4 and, or negative 4 and 1/12. So we are going to look at negative 4 and 1/12. So let's just say that's 1, 2, 3, 4, and 1/12, something like, maybe somewhere down there. We can graph right here and just one of the vertex. Okay, so we go here, and there's our parabola. That was a difficult one, dealing with a lot of fractions, common denominators, etc. But follow the rules, and everything should be good. Thanks.